Arrays. Arrays, by definition, an array by definition, is a collection of fixed number of elements, all the same type and in contiguous memory space. It's also a structured data type, where each data item is a collection of other data items, and it's made of simple data types. If you recall, some of the simple data types that we've worked with in the past were the integrals, such as int, double, char, etc., including enums, enumerations, if you recall from an earlier presentation. So this collection of, let's say, they're ints, all right. We have cool students here. Here's our first array element. Cool students 1, cool students 2. All right. This is what's known as our base address. This is what C++ looks for when you refer to an array. Okay. And when you have other int data types, all right, so this could be at memory location 1000, 1004, 1008. Int data type requiring about 4 bytes. All right, so if you say I'm looking for array, number 1 here, etc., it will then note that the base address is 1000, and then take 1 multiplied times 4, add that to 1000 to come up with and say, hey, cool students 1 is some particular value. So you can see here that they're all in a contiguous memory space in which all the data elements here in this example were all of an int simple data type. The syntax to create an array, this is simply the data type such as int or double, the name of your array. In the earlier example we used cool student. Okay, and of course you can list the int exp, which is basically the size. We had, I believe, 3 examples earlier. When you look for an element in an array, it actually starts at 0. Okay, so if I were to say 3 here, there would be cool student 0, 1, and 2. If I were to define the size of this particular array at 3, to actually assign or to look for a value, it would be cool student 0, cool student 1, cool student 2. All right. Having values in here would mean that I'm so-called in bounds. In other words, if the index right here, if the index is between 0 and the array size, I apologize, this is the array size. In the syntax, you can refer to it via the index here. If the array, it's considered in bounds if, Okay, the index is between 0 and the array size minus 1. Because remember, if you declare the array size of 3 here, okay, your indexes are actually just 0, 1, and 2. All right, there is no index 3. If that's the case, you'll be what's known as out of bounds. These are your 3 values here for an array size 3. If somehow you become out of bounds, which you must be careful not to become out of bounds, all right, you may end up accessing memory you didn't intend to access outside of our earlier example of the 1000, 1004, 1008. You may be out here in 1012, and there's something weird out here in this memory space. It should be noted in some of the compilers that we use today, I believe the one that I use for examples in our class, which is the Microsoft one, you'll receive an error message. You will receive an error message. I have when I was playing around with it. At least that's my recollection. Some restrictions on arrays. There are no aggregate operations. All right, if you need to copy one array to another, you need to do so one element at a time. Let's look at an example. Okay, here's our example, simple one-dimensional array. I've included also here my header file for string because I'm going to declare a string or a variable of string data type. Here I said constant int number of houses equals 4. This is my array size. There we go. And then string houses number of houses, which is my array size here for 4. If I wanted to, I could have initialized it during declaration. In other words, put the values into it by saying equals to Gryffindor, Ravenclaw, Slytherin, Hufflepuff. All right. Instead, in my program, I'm going to ask the end user to enter in those houses by using this for statement, for int I equals 0. I is less than the number of houses. I plus plus cn houses I. So here, my inbound values for my array would be between 0 and 4. Anything else would be considered out of bounds. And then here I say, don't worry about this for now. For int I0, I is less than houses plus plus C out houses. In other words, to print out what the user entered. Let's go ahead and do that. Gryffindor, Ravenclaw, Slytherin, and Hufflepuff. And it spews out the exact same thing. What I'm showing here, I'm going to go ahead and comment this now, is that if you recall, you can't copy aggregates, but you can copy elements of aggregates. So what's going on here is Draco's being a bugger. Remember, you can't assign aggregates, only one element at a time. And here I'm assigning one element within the same array to another element within the same array. If you wanted to, this could be one array and this could be another array. As long as you're assigning elements individually, you can't do it aggregately. So here, let's go ahead and run it. And it's going to be Gryffindor, Ravenclaw, Slytherin, Hufflepuff. And we notice that now something is different. House 2, okay, houses 2, element 0, 1, 2, 3. Those are our 4 elements with index 0, 1, 2, 3. So at index 2, 0, 1, 2, Slytherin has now been assigned to index 0. So therefore Gryffindor has been replaced by Slytherin. Slytherin is in there twice because Draco was being a bugger. That's it for our simple one-dimensional array example.